Okay guys, and let us discuss about advanced flow control, and the first topic that I want to discuss in advanced flow control is nested loops. Now let us create another class over here, and let us name it as advanced flow control, and let us take the public static void main and let us finish this thing. And in this advanced flow control, first one is nested loops. Now first off, loops can contain another loops, right? One loop can contain other loop. For example, considering this example that I'm going to do right now, you will understand what is a nested loop. Now let us first create a 2D array. Don't worry about a 2D array, and 2D array is just an array inside another array. That's all it is. So if I do int this thing equals to, so I would just say my complex array. So 2D array, that's why we have two brackets over here. If you remember, in 1D array we had only one bracket over there. So my complex array equals to, so basically a 2D array contains array inside another array, right? That is what a 2D array, or you can also compare it to a matrix which has rows and columns. So we'll just have this thing 5, 2, 1, 3. Then we have another array inside this 2D array. We have 3, 9, 8, 9. So these are all just examples. Like you see, for example, this is the first element of the 2D array, which is an array. This is the second element of the 2D array, and we have another array which will be the third element of the 2D array. So 5, 7, 12, for example 7. So this is a 2D array. You can also compare it like a matrix which has 3 rows and 4 columns, right? Now let us see this thing. Let us write a for each array for the outer loop. So for int this thing, this simple array, my simple array, colon my complex array. Now what is happening over here? Very easy to understand. Here what is happening? Extracting the elements of the 2D array. So if you see each element of this 2D array, and you learned about the for each array, right? Each element of this 2D array is a one dimensional array or a 1D array. So that is why this one is a single instance or a single element of this particular 2D array. So at every iteration we are going to get one 1D array. For in the first iteration we will get this array, in the second iteration we will get this array, and in the third iteration we will get this array. That's how it works, right? So that's why we have this thing at place. Okay, now we at every iteration we get a single 1D array, and let us iterate inside that 1D array again. So we'll use another loop right now. For int I equals to 0, I less than my simple array dot length, and then I plus plus, right? And sys out, let us say my simple array of I, plus let us give a tab space plus slash t, and instead of a ln let us use a print over here. And after printing that particular array, for example we printed this array, because this loop will print that particular single array, right? Single 1D array. So we print this one, and then we move to the next element, this one, and we print all the elements in this array, and then we move to the next array and print all the elements in this particular array. That is what is happening over here. Now after printing a particular array, particular 1D array, let us go to the next line, right? Now let us see this thing, let us see the output. Now see, this looks something like a matrix over here. So we first print this array like we did over here, and then we take a tab space, then go to the next line, print the next array, and then print the next array. So we deliberately mixed a collection of a for each loop, and inside that we have a common for loop, and this is an example of a nested loop. We have a one for loop inside another for loop. Don't worry about all the syntaxes about this 2D array and everything. This is very easy to understand, but still if you have any doubts, we are going to cover all these things in our arrays chapter. Let us see another example, right? As we do more examples, will be more clear. Let us see an example regarding while. Let us take int x equals to 20, and while, for example, while x is greater than 0. And let us do this thing. Do x minus equals to 2. So I am using some kind of shorthand operation over here. And let us say, okay, now let us write the while condition over here at the end, right? While x is greater than 5. And after the while loop, let us do a x minus minus and sys out print the value of x plus slash t with a tab space. Now what is happening over here is basically we have one while loop, and inside that we have another do while loop. What is happening? The first time the loop executes, the inner loop repeats until the value of x is 4, right? So this do while loop will keep on executing. It will keep on decrementing the value of x until the value of x is 4, because the loop will run till the value of x is greater than 5. So at some point the value of x will be 6, because we are decrementing the value of x by 2. So it is decrementing in an even with 2 every time, right? So it will be 18, 16, 15, 14, 12, 10, 8, 6, and then after 6 it will go to 4. So after the last iteration will be 6 minus 2 equals to 4. That is why it repeats until the value of x is 4 for the inner loop. The value will then be decremented to 3, because after the do while loop x is decremented to 3 because of this x minus minus, right? And that will be the output at the end of the first iteration. So 3 will be the output at the end of the first iteration, right? On the second iteration of the outer loop, the inner do while loop will be executed only once, even though x is already not greater than 5, because it is a do while loop, right? Even though this condition is false, it will be executed at least once. As you may recall, we know that do while always executes at least once. This will reduce the value of x to 1, right? Then after reducing the x to 1, then this particular thing will be getting executed, and basically this will reduce it to 0, and then 0 will get printed over here. And then the outer loop will also break, because x is now 0, which is not greater than 0. So we are also going to stay out of the outer loop now. So if you see, the output will be, what will be the output? We just discussed, right? So 3, then 0. You can see 3 and 0. That is the output we just discussed right now, right? So the output will be 3 and 0. So this is how you're going to work with nested loops, right? Now let us see some other topics about advanced flow control. Okay guys, let us talk about this break statement. Okay, let me just okay. So as you saw when working with switch statements, right, in our previous lectures, break statement transfers the flow of control out of the enclosing statement. Okay, the same holds true for break statements that appear inside of the while, do while, or the for loops. It's the same kind of structure, and it's the same kind of situation right here, as it will end the loop early, right? Because if you are running a loop and then a break is encountered, it will just break the loop, or it will end the loop earlier than it is, right? Now let us see this example that you see on the screen, and it shows a break with labels over here. Notice in this figure that the break statement can take an optional label parameter that you see over here, that is the optional label parameter. Without a label parameter, the break statement will terminate the nearest inner loop it is declared in, right? The optional label parameter allows us to break out of a higher level outer loop. Let us see an example of what I mean. Okay, so if I'm going to explain it in simple terms, we have this optional label over here, and this is the while loop, and it's an outer loop, right? If I say break optional label and it is the outer loop, we can also break out of the outer loop directly. But if we don't have an optional label, and if we have, for example, an inner loop over here, a for loop, and inside this for loop there is this break statement, then if this break statement is encountered, then we are going to go out of this inner for loop first. But if you use the optional parameter, optional label, then you have the a chance to break out of the outer loop also. Let's see an example to make things clear. I'm going to go into my Eclipse editor over here, and let us write some code and let us understand this thing. So let me just add some comments. Break statement tutorial or break statement example. Okay, here let us write some code. Let us take an array, 2D array, so int this thing, and I'm going to name it as list equals to, let us take an 2D array. So 2D array is an array inside an array. So we are going to learn about arrays later on, so don't worry about this thing. So 1, 13 and 5, then we have 1, 2 and 5, and then we have 2, 7 and 2. Okay, so we have this much of over here, and I'm going to take a search value. So int search value. I think you are getting an idea where I'm going to this, right? Just going to search the search value, that's it. And let us take position x equals to -1, and in position y equals to also -1. Basically we are going to search for this particular value, and if the value is found, we are going to return the the x, the row index and the column index. That's what I mean. Okay, now over here let us write a parent loop. So basically we are going to use an optional label parent underscore loop, and we are going to just say for int I equals to 0, I less than list dot length, and then I plus plus, and then we are going to write a child loop or an inner loop for int j equals to 0, j less than list of I dot length, and then j plus plus, right? And here we are going to write some code to find the search value, right? So if the search value is found, it means it is this current element, right? So list of I of j, so this current element, if it is equals to a search value, then basically what we are going to do, position x equals to I, so that will be the row index, and position y equals to j, which will be the column index, right? So that's we are going to do. And here what we are going to do is we are going to say break parent underscore loop. Okay, I think you are getting an idea of what I did right here, and let us add some more code, and then we are going to just do some other stuff. So I'm just going to say if position x, right, equals to -1, or position y, if it means that the element is not found, right, it means that the position of x and y didn't change from -1. That's what I mean. Then we are just going to say sysout search value not found, something like that. Let me just make it double quotations, my bad. And also, or else we found the search value, right? So we're going to say search value found at positions, and positions plus position x, and we give a space or we give a colon or something, and then plus position y. Cool stuff. Yes, now we are ready to execute this code. Let us execute this code and let us see what is happening over here. Control plus F11. So here if you see, here you see that we it says that search value found at position 1 obviously, because the search value is 2 over here, and basically if you see the second row, this is the second row, right, and this has the index 1, so that is why 1, and then it is present here. So for this array, this is the second index or index number 1, right? If I am going to show you a little bit of here, then it will be clear. So we have the array like this, right? We have 1, 13 and 5 like this, and then we have 1, 2 and 5, and then we have 2, 7, 2 over here. And if I'm going to write the indexes over here, if I'm going to write the indexes, let me just quickly make a matrix out of it so that it will be easier to understand. So 0, 1, 2, these are the row index, and 0, 1, 2, these are the column index. If you see 2, it is present at index number 1 and 1. That's why when we reach at that particular position, when the loops reach at that particular position I and j, so the position x is I and position y is j, because this if condition is true. And what we do if we found the particular position, we break the parent loop. So what is happening, a kind of call happens to this parent loop label that is present over here, and we say that break that particular loop which represents the parent loop. So parent loop points to this outer loop, so I am saying okay, break the parent loop. So this particular loop is broken, right? So if this outer loop is broken, then by default the inner loop is also broken. That is pretty much of common sense to understand. So we break out of both the loops, we can say, because we directly break the parent loop and we come out of this loop. And here obviously the position x and position y is not -1, so the else part is displayed over here. If we take the search value as something else which is not present in the array, then basically this condition is never reached. So basically it keeps on running and it doesn't find the search value, so the answer will be search value not found if we give a search value which is not present in the array. That's how we can use the break statements, right? But if you do not use a an optional label over here, it means that if I do not use this optional label and I just say break over here, then what do you think will happen? What do you think will happen? Instead of breaking the outer loop, this break will break this inner loop. This inner loop will be broken, but the outer loop is still not broken, right? Now what will you do to break this outer loop? What will you do to break this outer loop? You have to keep another condition for the outer loop to break. Like for example, you can just say if position x is right, you can just say not equals to -1, position x not equals to -1, and position y not equals to -1, right? And if this is the case, then we also break out of the outer loop. So if you're not using a optional label, then basically we have to write two conditions. One condition when we found the search value at a position and we break out of the inner loop, and basically we also found the position, we found the position, so we also break out of the outer loop by using this condition over here. So you can see optional labels also have some kind of scenarios where they are useful, but the thing is they are not that much used in normal coding practice, because they kind of make the code complex. If you have too many loops in your code, for example, then it can make your code complex. So this is how break works. Basically it is used to break out of your loop or a switch statement or any kind of, basically it is used in switch and loops only. So this is how you can break out of your loop, and you can also use an optional label. So let me just revert it back to the previous example where we broke out using the optional label. Yeah, that's how you use break. Now let us move on to continue statement. Okay guys, now let us complete our discussion on advanced flow control with the continue statement. So basically it is a statement that causes flow to finish the execution of the current loop. I'm not saying it breaks out of the loop or ends the loop earlier like the break statement, but what it does is it finishes the current execution of the loop. Let us discuss this in detail. Now in this particular diagram that you see in the screen, the particular photo or diagram, you may notice the syntax of the continue statement kind of mirrors that of the break statement. In fact, the statements are similar in how they are used, but the thing is they are used with different results. While the break statement transfers control to the enclosing statement, the continue statement transfers control to the Boolean expression that determines if the loop should continue. So in other words, it ends the current iteration of the loop. Also, like the break statement, the continue statement is applied to the nearest inner loop under execution. So what did I mean by that? So whenever a continue statement is encountered, and we can also use an optional label like the break statement, what it does is it goes back, instead of executing whatever statements that is underneath the continue statement, like we have a lot of statement below this continue statement, it will transfer the control back to the Boolean expression. So it kind of skips the current iteration of the loop. That's what I mean. Let's take a look at a particular example and let us understand it in detail, because examples are good, right? Let me just remove all these things from the screen and let us go and see a example. So let us go below it, and what can we do? Let us do this thing. So we can just say first char loop. Let's take this, and this is optional label, and we can just say for int a equals to 1, a less than equals to 4, and for example a plus plus, something like that. And let us take an inner loop now. Let us say for character or car x, let's say x equals to a, x less than equals to c, and then x plus plus. We have already used x somewhere, right? That's why it is saying that x has already been used somewhere. Okay, we have already used x. Let us take it as c. Okay, let's take it as c. And okay, now in this particular loop, we are going to say if a equals to 2 or x equals to b, then what we are going to do is we are going to say continue the first char loop, and then if this is not the case, then we are just going to say sysout a space with, let us take a print instead of ln, space with plus a plus x. So what we are doing in this case, let us understand the structure. So with the structure as defined, the loop will return control to the parent loop anytime the first value is second, or like 2, or the second value is b. This results in one execution of the inner loop for each of the 3 outer loop calls. The output will look like this. What is happening over here? Oh, I made a mistake over here. It should be C. My bad, bros. Okay, so the output is like this: 1a, 3a and 4a. So what is happening? Whenever the value of a is 2 and c is b, we basically skip this particular sysout statement and we just continue with the outer loop. That's it. So for the value of 2, it is basically skipped. 2 and b, right? It is basically skipped. And for other values, we just print the value as it is, like this. Alright. So what if we remove this first char loop, right? So basically what is happening in this case is, whenever this particular condition is met or it is true, the control is returned back to the outer loop. Okay, so it stops the execution of the inner loop entirely and the control is returned back to the outer loop, and we continue our execution at that point. But what if we remove this loop, remove this label, right, and we just use the continue statement as it is and we remove it from here? So basically what will happen in this case is that the control will return to this nearest inner loop instead of to the outer loop. So the output will change also. So the output will be like this. So for each value of 1, that is for the outer loop, the B is skipped because this condition is true. So the B is skipped, so we get 1A and 1C. So the 2 is entirely skipped, right? For 2 it is entirely skipped because this is always true. So when A equals to 2, this is true, so none of this is printed. So it comes for the value of 2, this is true, continue is encountered, goes back to the inner loop, and then for B also this is true, for C also this is true. So the entirety of 2 is skipped because this condition is true every time. Then we go to 3, right? Then we go to 3. For 3, this is never true. No, it is true when 3B happens, sorry. So for 3, 3A is printed first, and then 3B is skipped because this condition is true, and then 3C is printed, right? Then same thing for 4, 4A and 4C. So instead of returning the control back to the outer loop, the control is returning back to the inner loop. That's why we are getting this new output in this case. So remember that using optional labels is kind of a boon in some cases, but you can do the same thing by coding a little bit better, because usage of optional labels kind of creates a pain if you use a lot, right? It will create a lot of confusion. So yeah, it's up to you when you use it or not use it. And basically that's it for this particular section. So we are done with advanced flow control. I hope you guys understood this thing, and we are going to return in our next video. Till then, bye bye.